Hello everybody. Now this is the last project that I will explain because there's one very important component that is very useful. I want you to know this for sure before the course finishes, and that is Rotary Encoder. The potentiometer is like controlling the resistors, uh, but we have a digital version of the potentiometer. It's not measuring the resistor. It is just used for sending signals depending on the direction that the rotary encoder is turning. You can see it in the different machines. Maybe in the washing machine you have a rotary knob that you select the modes, or many other machines. There, when you see you can feel that they are like tick 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 moving like that. This is a rotary encoder. We will do a project with it, and the project is 3.6. So the 3.6 project. Let's explain what it is. In this project, we will have one LCD, one transformator, and a relay. The relay can be, for example, a lock of a safe, and the rotary encoder can be installed near the safe, and by turning the rotary encoder, we will have a digit from 0 to 9 shown on the LCD. And anytime that we press the rotary encoder, there's a push button in that also. So there's 3 different pins here on the rotary encoder. 2 of them are sending pulses when you turn it. And when you press the push button, press it down, it connects the switch pin. It works like a push button. Connects it to the ground pin that is on that. So we have to give 5 volt ground, switch, and 2 signals. Signal S1 and S2 are basically the pins. It will be connected like this, 5 volt, and ground I am not showing here. I have not connected yet, but they are needed. 5 volt here, ground here, signal 1, signal 2, and key. Anytime you press it down, the key is connected to the ground, so it connects to the 0 volt. It works like a push button. So in this project, we will connect this one to the PD6 and the signals to PD2 and PD3. Why PD2? They are specific PD2 and 3 because they are the pins for interrupt 0 and interrupt 1. We want to use external interrupt in our project. We have a push button also that is connected to the PB1. This is all the connections. The PD7 will be connected to the base of the transformator, and it will power up basically a relay. It will connect the relay. Why we are not using again to directly power up the relay? Relay takes a high current and power, so we cannot pass that much current through our microcontroller. So we activate the transistor, and transistor is activating the relay. And the relay is actually we can turn on. We can use the external power source or one of these VCC pins for the relay also. That's fine. Let's see. What else is here? LCD is connected the way that we have done before in the other projects. So this picture side is, and now I'm going to explain how this rotary encoder works. When we want, this is like that when you turn it to clockwise, both of the S1 and S2 are starting to send signal. When you turn it, let's say from here, when you, S1, when you turn it, for example, to clockwise, S1 starts, gives a high value, like a few millisecond, like 50 millisecond later. It's not exact, 50, 10, 20, whatever it is, but let's, it's just for showing how it works. When you start to turn it clockwise, it will start to give you a pulse. It goes high, the value, and a few milliseconds later, S2 goes high. So this way we can recognize with the interrupts. This will be connected to the interrupt S1 and S2. And when right after the interrupt is activated, it means that this is gone high, the interrupt is activated. In this gap, it will compare the value of this S1 to the S2. Then it will see if they were equal. It means like this one. You see here they are equal when this is activated. The interrupt one S1 is activated. If it was here, they were in the same. They were equal in here. But if they were not equal, means that it's turning clockwise. And if they were equal, it means it's turning counterclockwise. And the same is about the interrupt 2 that we will connect this. This one, S2, when it is like activated, in this gap, it will feel that they are not equal. So this will know that it is counterclockwise. And if they are, and this is the opposite for the S2. S2 should sense that when it's activated, should sense that they are not the same. Yeah, in general, both. When they are not the same, it means that they are turning to that direction. S1 is to the clockwise direction and S2 to the counterclockwise direction. And this is how they detect the direction, and with every turn that few degrees that you are turning, it sends another pulse. So that is how it works. And let's go to see how we will use this for increasing and decreasing a number. We have a passkey in our project. Let's go see. We have a passkey. It's like a Pincode that we define for our project, and we have a char pass that we have to fill it using the Rotary Encoder. We have to digit by digit add to this this number, and then we will. This is used for the printing. It's not for the number is integer. Integer is the number that we will increase it, and we will basically we will select the digits of this number. So for example, first we have to enter 5, then we have to enter 4, then 3, then 2, and after this entering, we will compare this number's value. If it is equal to this password pin code, our programmer will open the like a door, for example, door of a safe. If it was not like equal, it will keep the door locked and say wrong password. This is our project. So we will insert a number with using the Rotary Encoder. If it is the correct number, that like it is 5432, it will turn it on. it will turn the output on and which activate the relay and open the door. If not, it will say wrong password. You can try again after that. So we will use two interrupts. So we will activate in the in the code vision. We activate them like this, and it generates a function like this for us. And another interrupt 1, is a function like this. First, let's go to the main code, and there we will see. LCD clear number. We give a 0 value to the number at the beginning. Then here this part, this green curly bracket part, is for updating the number. The number we are inserting here, and when the number reaches to the 4 digits, it comes here. And here it controls if it is equal to passkey, opens the output, port D7, and says it's unlocked. Otherwise, if it's not equal, then it will say port is it will close it and then say word wrong password. Yeah. And then this is just continuation. This will be a loop. How it is increasing the number, let's say here. We have to, let's go up. I explain how we are creating the number, like the digits. We will use Rotary Encoder. In the interrupt, as I said, one of them will detect the S1 signal first, and it means it's turning right clockwise, and the other interrupt detects when it's turning the counterclockwise. And here we will just say delay 1 millisecond, so that this delay is for stabilizing the pulses, because interrupt starts right away after the pulse has come. Here we give 1 millisecond delay to it, so that it is like the pulse has been stabilized. The interrupt like starts comparing it now. It compares the value of, you see, pin 2 and pin 3 means the values of here. Pin 2 is this one and pin 3 is this one. It is in this gap now in the interrupt 1. It compares. If they were not equal, where is this? Okay. If they were equal, it means it is in the opposite direction, does nothing. Yeah, it does nothing. There's no else for it. If they were equal, it means it's clockwise. Okay. No, if they were equal, it will increment the variable that is called temp. The temp is a variable that we decide to be between 0 and 18, because when you are turning the encoder, it's very hard to like control it very precise. So we multiplied 0 to 9. Every digit is from 0 to 9. We multiply it by 2 so that we can have better control while turning the rotary encoder. And after that, when we, for example, we want to get 7, we reach to the 14 or 15. Any of them reach, we will later divide this number by 2 so that we can use it. In the screen, we will see actually 6, 7, 8. We will not see this 17, 18. While we are printing, we will divide this by 2, and then here is just for having better control while we want to select the digit. So when the rotary encoder is turning clockwise, it will give us increase the temp by 1. With the next pulse, another one, and unlike that, it will go forward. If it is, for example, here, if pin 2 and pin 3 are equal, it means it's going to the other direction. So if it will control if the temperature is bigger than 0, it will decrement the temperature. This is because we don't want to go to the minus ranges. We want to be in the plus ranges. And the 10, 0 to 18. It should be between 0 to 18. So in the interrupt 1, we increment if it's clockwise turning. In the interrupt 0, we increment. In the interrupt 1, we decrement. And this number is this temp. That is the digit that is we are now selecting is this temp. Save there. So we come here. We say while number is less than 10,000 because less than 10,000 means is three digit 999. If it is 10,000, it's already 4 digits, so it should come to here. So if it is, we say while the number is less than 10,000, while the number is 3 digits, do this. I to A is a integer to array like a converter function. We say we need to convert our integer to array of the characters in order to print it in LCD. So here we turn the number into the array of characters, then we print it to the LCD, display it on the LCD. Then we display a comma with this puts F. Then we here is where we like divide the temp by 2, so that the 0 till 18 here becomes 0 to 9. Now we divide the temp by 2, so we have a number from 0 to 9 converted to the array, converted to the character. Then here we show it on the LCD. So this also goes to the LCD. Then after that we have this while pin D equals, this is the push button that is on the rotary encoder. While this is pressed, this means while this is pressed, while it's pressed, wait here. When it's released, it will pass from here. Number will be multiplied by number will be equals a number multiplied by 10 plus temp divided by 2. So for example, here we have number is 12, for example, and the temp is 16. We will basically we are adding this digit temp divided by 2. For example, it's from 0 to 9 to the right side of this number. Here we had, for example, 16 is temp, so divided by 2 will be 8. We add it to the right side of the 12. 12 times 10 plus 6 divided by 2. This is this formula. So we are adding the digits one by one to the right side. And then we make a delay, and then we clear the LCD so that we can write it again. So here continuously is running until the 4 digit is inserted. If the fourth digit comes here in the next round, we put here, some number will come here from 0 to 9, and this will be 4 digits and bigger than 10,000. And then this is not correct anymore, so it will come here. If number equals this passkey that you saw in the beginning, if they are equal, it will open the door and say it's all unlocked and delay 2 seconds for so that we can open the door and then deactivate the relay. If they are not equal, it will turn off the output, say wrong password, and clear the LCD and go out. This is basically entire code. Interrupt 0 and 1 are activated. The configuration you can see. This is the ports that we should make. Pin B1 was data direction of the B. Oh, it should be input, and it's not pulled up. Any of them is not pulled up here. Okay, but we have to make them pull up. And here it's not. Like, yeah, I have to make it pull up, like by adding the comment to the code. Interrupts 1 and 0. External interrupt, yeah. External interrupt 0 is on, interrupt 1 is on, and this is achieved by this configuration of the registers. You know what registers are now. Like int 1 is on, int 0 is on. This register, I don't remember exactly what it does, but they should be in this configuration. Int flag should be this one, int 0 flag 1, flag 0, yeah, interrupt 0 flag should be here, interrupt 1 flag should be on also, so we will use them in the code. Now let's go and yeah, this is the explanation. Now let's go to the code vision and let me close this, and I will show how to make the new project for it. So interrupt 0 and 1, we want them to be on, and we have the picture there that shows us, and the picture shows us which pins are connected where. Those are also the ports. We need to only set the ports and ports. Let me check again. The ports. This pin B1 should be pulled up. Input here pulled up. And pin D6 also input and pulled up. Pin D7 should be output. Pin D2 and 3, I think they should be pulled up because they will give signals. No, they should be in the tri-state because they are getting signal from the external device. They should be just tri-state. So let's do this. Pin D7 output. There are 2 pins input. Pin D7, let's put it output already. This is input and pull up because this is the switch from the Rotary Encoder. Pin B1 is input and pull up. It's connected to the ground row push button. And external interrupts you can see here. Only this and this. With the low level, you can say any change. Or falling edge, rising edge. It doesn't matter, you can say any change. And any change to this one also. Okay, and that's it. All you want, save, generate, save and exit. Let's give a folder here, new folder. Rotary Encoder. Rotary or Control C again. So the code is created. Let's see here. We were supposed to add stdlib. Stdlib is for control. Stdlib delay some functions that we need for sure. Delay. stdlib is anytime you wanna use LCD, you need to use the stdlib function. I to A and A to E are in this one. In the interrupt, here you were supposed to just increment temp. In here you would decrement temp. Then here you come and explain int temp number. So we had I also. We need I also for using some loops. And then was the char. What's this? A char. What name was the? Hey, let's put upass. Upass 4 characters and that's it. So these are the what we needed to define. This is for printing the displaying the characters in the LCD. These are the number and the variables that we need. Here increment the temp. Here decrement the temp. We need the pass key also. Int pass key. Or Pincode, whatever. You can just put the number. And here I put 1, 2, 3, 4, for example. So this will be our Pincode. This will be this. And just the pins I have to check. A is okay. DDRB is. This is pulled up. Yeah, in the other one, it was not pulled up. It's correct. The B1. D 7 is pulled up and 6 is 7 is output, 6 is pulled up input, and all the others are fine. Let me just go check this here also. It should be D should be on. Yeah, here is okay, and here is on. Just I don't know. Maybe there was a mistake here later, has to be fixed. DDRB. B1, we needed to have it. This was supposed to be 1, but if it's not, then I guess I have added it in the end of the code. I forgot to activate LCD here. So in our code right now, we don't have the LCD activated, but I think you know how to do that. So like during the configuration, you add the LCD also. It should be 16 characters, 16 times 2. And yeah, the pins that you are connecting, you will select based on this. Port C, it will be going. And that's it. Yeah, I just forgot to put the LCD like initialization here. But in general, that's all. I don't see any. So I hope everybody, any question during the classes, you can just ask, and I will try to help. So yeah, good luck to everybody.